Hello. Hi. Hi, Puri. Shall I start now? Hi, Brian. So I
Yeah,
will.
yes. Yeah, I think we can start now. Now I'll just introduce you. Well, since it's 12 o'clock, I think we have enough attendees today. Thank you so much, Sujan, for joining us. For everyone on the call, thank you so much for taking time to come and learn about what opportunities we have in the hydro space. And as a warm welcome, Sujan, I believe has been working in PNG for quite some time now. He is over 10 years of experience in the industry, not only locally but globally as well. And Sujan, we're really grateful to have you here to share what your company has been doing in PNG and what opportunities that we have also in the hydro space, and also for everyone else to learn about how we can better or look at what challenges we have and look at the opportunities that we could elevate our technical skills as well. So without further ado, Sujan, thank you so much, and I give this to you.
Okay. Thank you, Brian, for the introduction, and thank you, Brian and IEPNG, both Mosby branch, for inviting me for this presentation today. So let me start my presentation. So today I'll be discussing about like hydropower projects development, engineering challenges and opportunities in PNG. So I have made my presentation quite generalized because if we go deep down into a particular matters, there's a lot of things to talk, and maybe the hydropower could be a kind of new topic or new subject to many of the engineers, as there has been some gap in the development of hydropower projects in the country. So I have tried to keep it more generalized, so to give more overview of hydropower projects, what are the challenges, what are the opportunities. uh, so let me start. Brian already introduced me. So just to introduce SMEC. So SMEC is one of the global leading engineering consulting firm in infrastructure and energy sector, and particularly in hydropower sectors. Our expertise is globally we're among the top five consulting engineer firms in hydropower sectors. And in relation to PNG, like we are one of the international, like multinational company who is based in PNG for almost 49 years now. So we have our strong presence in PNG since 1976, when we started with Highland Highway, and we're involved in many old hydropower projects. So we have a legacy in PNG in terms of infrastructures and energy development. So first to start with, so for many of us might know that the hydropower will produce the power, but might not know the mechanism even if we are the engineer. So I just this is the introductory slide for hydropower. So first I'd like to like the just start with this equation: power equals to rho z qh. So many of us might have known about this equation, the formula for power, like when we were doing our schooling in the physics or when we were doing our engineering in fluid mechanics. It looks very simple, that we get the power when we have flow and when we have the heat. It's a very simple in terms of hydropower. But and we might have solved a lot of equations, or the practice, like we might have solved a lot of means problems using this equation in our assignment, in our exams, and we might have passed the exams, and we all came through that. But when it comes to the actual like uh, practical things, and when it comes to the actual implementation of these projects to get the power, it's not as easy as it looks simple in the equation. To get that, there are a lot of challenges. but with the challenges, it provides a lot of opportunities. So if you see here, like in terms of challenges or the things that are involved to get the power, like we have we need to have the specific information like hydrology, topography, geology, seismicity. Then once we have the site specific information, sometimes that site specific data might be favorable, sometimes it might not be much favorable, and we need to do innovations or we need to do our engineering, and then based on that we will do like engineering. And especially in the hydropower projects, hydro it requires like experts or specialties from various fields of engineering. Within the civil also, like it requires hydraulics, hydropower, civil, structural, geotechnical, even the roads and highway engineer for road components, tunnel. And if we go others, like discipline of engineering, like electrical and mechanical are one core disciplines that involves in the hydropower sector. So it's a hydropower is not a single discipline of engineering. It's a complex with the integrated, uh, uh, of different aspects of the engineering. And in in addition to that, in addition to engineering, like the development of the hydropower projects also requires like supporting infrastructures like access road, transmission line, which is very crucial for the development. And then environmental and social impact, and particularly in PNG, with our sociocultural background and this customary land issues, like environmental and social impacts also plays, and the land acquisition plan also plays very important role in the development of the hydropower projects. So this is in general. And what the benefits of hydropower are is clean green energy. We'll discuss more later on this. So there's energy security, as you don't need to depend on overseas supply, like for the fuel, for diesel, for gas, and it is crucial for the development of like any industrial development or any mining sector. So in general, like a hydropower could be like a storage reservoir scheme with the dam, like you have seen, some of you might have seen Idebu hydropower, Yonki reservoir, and some could be simple run of this river scheme like Rauna Cascade scheme. You might have seen, and there are few projects like peaking our world. Such projects we do not have here in PNG, but they are generally like designed to store the water for maybe 3 or 4 hours so that the plant can run in full capacity during the peak demand time. So in PNG, we don't have such projects till now. And the pumped storage is now the new concept basically in the countries like Australia, India, UK. This is growing, but PNG, we're still in the stage of development of our run of the river scheme hydropower project and a few storage scheme. So pumped storage is basically for peak demand as a battery storage. So it might take some time in PNG to develop the pumped storage projects. So now coming to PNG and its hydropower potential. So hydropower is the gift of nature for like not all the country can have the potential to generate power from hydropower, because as you all already understood, like hydropower is relation of head and flow. So you need to have a good hydrology, good rivers, and you need to be supported by the topography. So you can't build a hydropower in a flat river in a plain land. So normally the hydropower projects are built in hilly terrain where it is supported by the topography. And in terms of PNG, like if you see, we have highlands where the topography, the rivers are flowing with high gradient, so we can easily generate a good head from them. And from hydrology point of view, like PNG is has a very good hydrology compared to other parts of the world. I can show you the in the another screen, I can compare it with South Asia, like how PNG stands. But normally PNG has very good hydrology, which is very beneficial for the development of hydropower project. And in terms of hydropower potential, so there has not been any proper study for assessing the hydropower potential of overall PNG, but few of the assessment done before, like by World Bank, it says PNG has around 20,000 megawatt capacity and technically feasible around 14,000 megawatt, and we have not yet like tapped even the 500 megawatt. And though we have tapped less than 2% of the hydro potential, but it contributes for 39% of the total installed capacity in the country. And we all know that the electrification in the PNG is less than maybe it might have reached 15% now. And there's a lot of things to do in terms of electrification in PNG. And with PNG being blessed by hydro because of its nature, so hydro power projects can contribute a lot in the electrification, in the industrialization of the PNG. So this is the comparative chart flow duration curve I was showing you. So if you see, this is from Nepal, so where 98, 99% of the electrification is done from hydropower project, and this is PNG. If you see, most of you might have studied this flow duration curve in your hydrology course. So if you compare to flow duration curve, look how nature has blessed PNG with very good base flow. That means even in the dry season, the flow in the river doesn't go that low compared to other part of the country, mainly in South Asia, like in India and Nepal. So the hydropower development, like for a similar condition, we can get around 80 to, let's say, 70 to 80% plant factor in PNG, while we're getting around 40 to 50% plant factor in, let's say, Nepal. So the PNG has very good potential in terms of hydropower because of good hydrology. So that what I was trying to show. And this is the electricity generation status of PNG. So if you see, hydro is contribute 82% of the renewable energy capacity in the country, and and out of total supply, so 42% is contributed by renewable energy. Now, to understand the challenges in the development of the hydropower projects, we first need to understand the stages in the development of the hydropower projects. So most of you might have heard, or you might have like read in the newspaper that the development of the hydropower projects takes time. It's not like building a building or building a road. It is a bit more complex than other infrastructure projects because it requires stages of the study before actually it goes into the construction. So normally the stages of the study in hydropower projects are first is like desktop pre-feasibility study. So in desktop study or pre-feasibility study, what we do is, yeah, if we have a area of interest, or if we are given some locations and we're asked to like identify the hydropower potential within certain distance from that point, then we can do the very high level desktop study to identify the hydropower potential of the rivers within that area. So this is one example that SMEC has done in PNG. Like we did a pre-feasibility study desktop assessment of potential hydropower projects in Finsafen district in Papua New Guinea, and we have studied all like major rivers there, like Kuat, Mungi, Burum, and Mape. So now our assessment shows that those rivers in that particular district can generate around 500 to 700 megawatt capacity of hydropower projects. And during the desktop study, so we need to rely on, because we can't do or we can't invest in detailed site investigations because of time and cost, as this is high level study. So we need to rely on freely available satellite data for topography, and we have a limited hydrological data that I'll discuss later. Also, one of the challenges in hydropower development in PNG. So, because we don't even have the time to install the gauge station during these early phases of the study. So, with the limited hydrological data and the limited site-specific information, we normally uh, like focus on freely available or readily available data for doing the hydropower potential assessment during the pre-feasibility study. So this is some of the assessment. Normally we do using GIS based software, and sometimes the program, if the area of interest is quite big, then we need to do programming in the GIS software so that it assesses the flow and the height, the gradient of the river and the catchment area to give us with the optimum hydropower potential projects within the given river basin. Now, when it after the pre-feasibility study, so there are few projects that might be selected to go for the feasibility studies. So during the feasibility studies, normally pre-feasibility study takes around 4 to 5 months, sometimes 6 months, depending on what area we are looking after and what level of details we are doing. So after pre-feasibility study, so feasibility study easily takes around 10 to 12 months for the reasonable size of the run of the river projects. For dams and big storage projects, it's a different story. So in the feasibility study, a number of discipline of engineering requires the input from number of discipline of engineering is required during the feasibility studies. Like to start with, the topographic survey is the one key, like site investigation is one key activities during the feasibility studies. So within the site investigations, the topographic survey, bathymetric survey, geotechnical soft surface investigations, these are the major site investigations work that are done. And in addition, in the high seismic area, we need to do site-specific probabilistic seismic hazard assessment. And we do the feasibility level design and costing. I will discuss regarding the challenges that we face during the, what are the engineering challenges during the feasibility studies based on the specific topic later. And this is part of the feasibility level design. So once we have the site-specific information and data, so we have the opportunity to develop the project layout. So here comes the input of different discipline like civil, hydropower, hydraulics. So if you see this image, this is related to what we are modeling, the river flow modeling in HECRAS software. And we do a lot of analysis like from civil, hydraulics, and hydropower point of view to come up with the layout. So it's an opportunity. So in normally in a hydropower project, so there are constant, like it's not like a building. So where you have the free area, you design the building and construct it, because you need to develop the hydro project in a very rugged terrain. So sometimes you might have the space constraint because of topography. Then there comes your engineering innovation, there comes your engineering judgment, where you have to sit, you have to think, you have to rely, you have to consult all these geotechnical, topographical survey data, and then come up with uh, proper solution, engineering solution for the project layout. So normally we focus on the development of the project layout during the feasibility studies from the input of site investigation related works. So once the feasibility studies is done, for any particular project, so after 10 to 12 months, then the next stage is tender design, detailed design, and construction. So normally, many of you might know that there are different types of contracts. So based on the type of contract, the level of design, tender design differs. So if it's the EPC contract, so the tender design is very high level, where the it is more focused on specifications and concept arrangement. And but if it is a red book contract, then it is more a detailed level of design or detailed level of drawings. So once the tendering is done, then there comes the picture of detailed design. So normally up to feasibility studies, we don't do detailed design like structural, dam, stability, tunnel, like hydraulic modeling. These are generally not done during the feasibility study. So we normally do this detailed level of design during detailed construction level design. So if you see it here, so this is the finite element analysis of the dam. So we normally use the FEM based software to assess the stress analysis of the dam for different loading conditions. Um, and we do the structural analysis for different components of the hydropower projects like intake, settling basin, power station buildings. So there are a lot of complex things involved in hydropower projects. It's not simply one like particular component. There are a lot of component, and the engineers involved in the different phases of the hydropower projects can get the opportunity to learn about many aspects of like civil engineering, like departments. But later, based on their interest and based on their focus, the expertise can be developed in one particular area. But overall, in general, as a hydropower, you'll get like opportunity to learn many aspects of civil engineering. So in hydropower, like tunnel is involved. So not in all the projects, but in some of the projects, the tunnel is a very like important component of hydropower projects. So you need to design the tunnel. There's a you need to design for rock support. You need to do like rock support modeling, stress analysis once you dig the tunnel, and what kind of support you need to provide. So that is related to rock engineering. So you need to carry out the geotechnique. There are a lot of slope coating in like when you do the detailed design, when you do the project layout development, there are a lot of excavation work. So permanent slope protection is required. And here comes the picture of like geotechnical engineer to design the slope, to design the foundation of the various project components. And hydraulics is one key aspects of hydropower. So where you need to do hydraulic modeling to verify various flow condition, to verify the transient modeling. So this is one of the projects in Australia where this Flow 3D modeling was done to assess the spillway capacity during the flooding. So this kind of like engineering is usually done during the detailed design stage. And all of you might know after this that we normally produce the construction design to go for the construction. So now the project construction phase. So if you see, like I've kept some pictures of the projects you are aware. So some of the recent projects. So the one close to Port Moresby is Idebu. So because it was built recently, so many of you might have got chance to visit this project, or you might have heard about this. So if you see, like it took almost 14 years to develop this project from concept to operation. So that 14 years, if you look into that 14 years, so it was not actual construction that took 14 years. There are a lot of, apart from engineering challenges, there were a lot of like challenges. There are a lot of challenges that are involved in the development of such big infrastructure projects. So when it starts with a desktop study, things does not go smoothly because you need to manage social things, you need to get your power purchase agreement, you need to have a relevant approvals from the government authorities, you need to get financing. So all these things takes time, but if you see this project was normally massively built during COVID time, so really it took more than 2 or 3 years just for the construction. But if you see the development period is a 14 years. But if the project goes smoothly, it can be easily built in 8 to 10 years also, right from the like desktop screening study to the operation. But there sometimes because of a lot of hurdles, there like the project gets it takes time for the project for development. Now, many of you might have a curiosity like if it takes so long to develop the hydropower project, why can't I just have a genset, buy the fuel, and do power up my like house or any industry, just do the genset and use that as a like power to supply or to run their operation. If we look at very surfacely or very simply, it, it makes sense. But if you compare it from commercial point of view and the climate change point of view, it is not sustainable to have the fuel based like power. Even if it takes some time to develop the hydropower project, even if it takes some initial cost, if it requires some initial cost, but the benefit the project will give for another 50 years or more than 50 years is much more than the initial investment, like given in consideration of time and cost. So the live examples for such for that statement is all the old hydropower projects that are built in country and serving the country are or they are kind of helping PNG power to sustain. Like if you see in Ramu Grid, Ramu, Yonki, if you see in Patmosby Grid or Rauna, and now with Idebu. So you can imagine if there were if these projects were not built like before 50 years, because most of them like if you see the old projects Rauna, Ramu, Paunda, Rauna, they were built almost 50 years before. If these projects were not built at that time, the country would have been in the very difficult situation in terms of energy, in terms of power supply, because it would have been a nightmare to supply the power provided by these projects by using any genset or let's say gas power. It would have been very costly, and maybe it would have cost a lot to like PNG government or the PPL. So now like there has been a lot of gap for the development of these projects. Uh, so it's the right time or it's already late to develop other hydropower or to initiate development of the other hydropower projects in the country. So I just want to show this another project that was built recently in 2021. So this is Divuni hydropower project. It's a small 3.5 megawatt project in Oro province. So if you see it here, so I was involved in the some of the design review and construction, intermittent construction supervision of this project. So SMEC was a consultant. So in terms of challenges during the construction, so what we encountered in this project was when we're doing the concreting, uh, the temperature of the concrete was above the one that was specified in the technical specifications, so above the acceptable limit. Then what we have to do is we have to use the ice to cool the concrete to reduce the temperature of, so during the concrete mix design, so for the water content or water portion, so we have to use the ice to reduce the temperature of the concrete so that the concreting can be done properly. So we have applied all the measures for the proper concreting of the major mass concrete in the dam. So that kind of engineering or the challenges was due to the climate, which is natural, and but we have to come up with some solutions for that. So it went well. So even if you see this Divine hydro project. So like you see the settling basin, very simple structures here, but when we have to implement this, there are a lot of like uh, things involved. Like when you excavate it, if there's no proper rock, or if there's no, actually there's a good rock found in this project, but in general, if we say like if we are going to do foundation for any like components, like let's say settling basin, dam, or some intake, then when you excavate normally during the feasibility study, you'll have idea of what kind of subsurface ground condition you are encountering. But based on that, you do some design. During the detailed design, you propose some engineering solution, geotechnical solution to improve the foundation condition, or you might need to do the grouting if it's a fractured rock. So when you do the excavations, then you need to check all these conditions, do the proper again the geotechnical assessment, and if required the geotechnical treatment needs to be done, and you'll be then doing all this concreting reinforcement. So that there's a lot of tasks that is required to do during the development of such projects. And if you see this the powerhouse, so you see all these activities were uh, like considered, and the final output was like this, the hydropower project, which is now generating 3.5 megawatt of the hydropower projects. So in the in the power station, like for many of us it might look simple, as a there's a building, that's all. But during the construction of the power station project, there are challenges because you have to interface with electromechanical components like turbines and generators. So there should be the proper coordination between electromechanical team and the civil team, electromechanical contractor, civil contractor, and as an engineer who is in charge of supervising all these activities, he should have a very good idea of the interference of electromechanical and civil component, because any small misses can cause a blunder mistake. So like just say like for concreting, so there it requires like there are two stages of concreting in power station buildings. So during the first stage, let's say you build the raft foundation, and then you put the voids for the electromechanical components. So sometimes if someone is not aware of these stages, and if you do not leave the anchorage bar from the first stage, then there's a problem. So there need to be proper coordination between electromechanical and civil teams. So it requires very specialized engineering. And even like maybe the crane beam is also used in other projects, like in warehouse where they are doing our workshop. So in hydropower projects also, like their crane beam to lift this the heavy electrical and mechanical, sorry, generator and turbine. So if you see it here, civil construction is a almost 10-meter high dam. So there's a construction joint where you can see the shear keys, which is usually provided at the construction joint. Um, so such kind of speciality is required even during the construction supervision of the hydropower projects. So this is Baime hydropower project in Bulolo. So SMEC was engaged right from pre-feasibility study up to construction as a language engineer. So we started with pre-feasibility, feasibility, detailed design, and were involved in construction also. So if you see it, it took almost almost 10 years. So when we did the design, this is dam, this is power station, this is source tank. So when we did the design, that there's a lot of challenges due to sorry, when we were doing the pre-feasibility study, feasibility study, there were a lot of challenges due to topography, access, and everything. So later on, like when doing the construction, access road was built, and now the project is live, which is contributing a lot in Ramu grid. There's just few examples. So now in terms of I went through different stages of the hydropower project, so you can visualize how much time and what are the stages for the development of the hydropower projects. So now coming to the challenges. So every stages has its own challenges, and there's opportunity uh, to overcome the challenges. And as an engineer and as a technical engineers, it's a very good opportunity for us, like to to provide our engineering solutions for such challenges. So one of the challenges in hydropower development in general, not only specific to PNG, but in general, is topography, because hydropower projects are generally built in rugged terrain, hilly area. So during the initial phase of the project development, it's a like totally a virgin area where there's somewhere there might not be even the access road. There's a very like steep cliff, very narrow river valley. You need to go to the site, do the site investigations, like topographic survey, and especially in case of PNG, it's a very densely vegetated area, and it is very difficult. Like if you see, this is one of the project where the topographic survey was done by the lidar. You can't imagine, like if we have done this topographic survey by total station or by the ground survey method, it would have poses a lot of challenges, considering the topography, considering the area and time. So we need to do the lidar survey, so that usually saves our time. But still, with the lidar survey in the dense vegetation area like in PNG, there are some constraint because of this canopy, where it might not be properly captured, or even during the processing sometimes it might be some of the areas might be missed when the area is very large and the vegetation is very thick. So this is kind of topographical challenges. And also in the river, like normally we need to do the bathymetric survey. So bathymetric survey is the survey that is required to the cross section of the river. When the river is big, when the river is fast flowing, then there's challenge to do such work. But there are a lot of technology, like if the river flow is manageable, we can use the boat, floating boat. We have done that and do the survey. And if the river is very deep, like let's say Purari River, so you can use the sensor like in the boat and do the bathymetric survey. But these are the part of the studies that are generally required during the feasibility study, and there are challenges. So it's not an easy task. So due to topography and terrain, so it also poses the challenges when we're doing the geotechnical site investigations. In some of our projects, we have to use the helicopter to ship the drill rig from one place to another place, just because there's no access road, because this is very early stage of development of the hydropower project. So these are the challenges related to topography, and the challenges related to hydrology, like I mentioned before. So hydrology is very important, but if you see, in case in mm, context of PNG, so we have hydrological data of major rivers and some of the rivers, but those data were from like 40, 50 years before. Like maybe after independence, there are no gauge station properly established and monitored, so we don't have recent flow data. So I think that is like maybe some of you, or we as engineering community needs to push to the government agencies like SIPA and National Weather Services, because not only for hydropower projects, this plays a very crucial, these are the very crucial data for other infrastructure or the climate resilience design related planning, even for the road. If you need to have a breeze, you need to have a proper hydrology, and hydropower obviously is very important. But in spite of lack of data, also there are a lot of uh, assessment, or the hydrological analysis and modeling can be done based on the previous data and some of the data available, from open source. So that requires very proper skills and judgment, and a very expert hydrologist to do such analysis. And that can be done, like we can come up with hydrological analysis for flow duration curve and flood frequency analysis. But it is always recommended to establish a gauge station, because there might always be some risks. So normally during the feasibility study, we recommend client to establish the gauge station, but 1 years or 2 years data is also not sufficient. So the long-term data, hydrological data is always helpful. So that is one limitation, but we need to overcome that limitation with the proper hydrological modeling and hydrological analysis. And we do have a PNG flood estimation manual, which was prepared by SMEC. So that also gives a good reference. Sorry, I might be running out of time, so I'll maybe still 15-20 minutes to go. So another key challenges in the development of the hydropower projects and maybe the infrastructure projects in hilly terrain, hydropower is very crucial. Like geology is kind of foundation for uh, development of the hydropower projects. Because one thing what we engineers needs to understand is, like, for development of the projects like hydropower, so there are I differentiate it in two category. One is site specific information like topography, hydrology, and geology. That is that are the thing that is already exist in the ground. We can't do engineering for. I mean to say, we can't change that. So if we have a good geologist, if we have a good like engineering geologist who can do the proper interpretation and collect the site specific data, that is very important. So based on that site specific data, now the engineer, as an engineer, we can always provide the engineering solutions. We can play with the different options and come up with the solutions. But site specific information, that is like kind of fixed thing that is at the site, which can't be changed, but the solution can be made based on the existing site condition. And like I said, geology plays an important role, but the in PNG, the geology is very complex due to the tectonic movements, which is still active, and geological surprises are quite common. Like we have also seen such geological surprises while doing the subsurface geological investigations for hydropower projects. So with these challenges, like even landslide is quite common in PNG, like it's a seismicity induced landslide or rainfall induced landslide is quite common. And we have observed that there are like the landslide that has occurred maybe 500,000 years before, or we don't know, and has formed a very good waterfall in the river, which we can utilize for the hydropower projects. But the problem is that waterfall now has created the sedimentation upstream, and there's a thick layer of that what we observed in one of the projects, thick layer of clay or thick layers of alluvium, which poses challenges to build a big dam. So we need to come up with the proper engineering solutions to suit that site conditions, by reducing the dam, by changing the uh, type of the diversion we are proposing, and other few um, uh, challenges are sinkholes, and I don't know if you have seen or not, like in some cases, like where there's a limestone, the water enters inside the cave and exit from another end. That means river disappears at some locations. So we need to properly assess, do proper geological assessment, of all these existing geology at the site, so we can come up with the proper engineering solutions. So for that, we need to do a very detailed, or based on the stages of the study. So we need to do site investigation that includes geological mapping, geotechnical drilling, soft surface, this geophysics, which is usually to find the subsurface, and the drilling is one very important for subsurface geological information, and in situ test, like we do standard penetrometer test, standard penetration test, SPT, Packer test, to understand the uh, permeability of the rock. So, so we need to do very thorough investigations, uh, so that we can come up with the proper design. So there's challenges due to engineering geology. So if we do not uh, do the proper investigation, we will not have a proper data set or input data to do our engineering. So these are engineering challenges related to geology. So this is one of the geological cross sections where you can see that even the rock is here, the depth of the clay or colluvium is quite deep, mainly due to the landslide, downstream of it, and kind of lake formations during the early age, means uh, during maybe, let's say, number of years before. So such challenges are there. So that requires proper geological investigations and proper engineering solution. So hydropower is a very specialized engineering field, and expertise is very important here. And seismicity, I think all of you might know, like PNG is located in the ring of fires. So building any structures requires proper uh, site specific, like mainly for the major dams, it requires site specific seismic hazard assessment. For small projects, referring to available literatures on PNG seismicity, including the earthquake design code for the PNG is also sufficient, but for major dam and major big projects, site specific probabilistic seismic hazard assessment is required. So PNG, like I say, is within the active seismic area with active faults. So if you see the area, mainly the highlands, even if you see the layer where where we have the good hydropower potential, there also exists the risks of high seismicity, but it doesn't mean that it will stop the development of the project. So you can see the Yonki Dam, Ramuan, Warongoi, all like Yonki is located somewhere here, and Warongoi in New Britain. So all of these projects which are serving PNG, providing clean green energy, are located in very high seismic zone, and they are standing for almost 50 years. So if we do the proper engineering, there's always a solution, and we can get the benefit of that, projects. So seismicity will not uh, like uh, will not block us to for further development, or is not a restriction for the development of the projects, but it requires proper study, proper assessment, and the proper design. So if we are able to do that, then the benefit is much more than the cost we or the investment we do for the development of the projects. Like the Papua New Guinea is like it's in the like Australian, where the Australian and Pacific plates are converging. Because of that, there are a lot of movements and there's active faults. So now, like we talked about mainly on the development of the greenfield projects, the challenges, stages. Now, like most of the projects, existing projects in the country are like already more than 40 years. So now they are in the stage of refurbishment. So there are also the challenges in the refurbishment of the old project. So here I have shown few photos of two hydropower projects. One is Paunda, one is Ramuan, where SMEC was involved as a consultant for the feasibility study of the rehabilitation of these projects. So if you see in Paunda, many of you might be aware of the condition or some of the risks that Paunda hydro project is facing. It's mainly geotechnical risks. If you see this forebay, this is sinking because this forebay was founded in mainly fill materials, and with when we observed it, it looks like it's mainly in the clay. So because of plasticity, so and the load condition, there's a differential settlement, and the structure has been distorted, but it's still servicing the like PNG Power has uh, adopted some local solutions for to avoid the leakages, but this project needs rehabilitation, and these are the challenges. And as an engineer, we can come up with the solutions. Like we have studied the various solutions for this, the geotechnical treatment of this foundation. And with the brownfield projects like rehabilitation, greenfield, there's nothing you have a choice to do with your engineering. But in refurbishment, in the brownfield project, you're not going to completely remove that, and there that requires more challenges, and that requires more innovation and engineering. Suppose for these structures we are not allowed to suppose if we are not allowed to build a new structures, then we need to see the innovation of geotechnical treatment without replacing this structure. So this kind, like if you see it here, this is around the intake of Pounder. So there's a rock fall happening. So this is a and this rock fall is impacting the head-oaks structures. So we have proposed some solutions for the slope support and rock fall protection for these structures. So and in terms of electrical and mechanical engineering, so the equipments are already old, and that needs to be uh, replaced, or some of them might need some replacement of the some parts. But when the project is normally more than 40-50, it requires a complete replacement of the turbine and generators. So there are challenges, and one of the big challenges now PPL or government is facing is, even though these projects are not producing at the full capacity because of some like constraint with mechanical and civil components, but more challenges is now because PNG was not prepared, or there's no development of the hydropower projects in last, let's say, 20, 30, 40 years after these all old projects were built. And there are very less number of the hydropower projects that came online in operation, maybe Idevo recently, and then some of the PNG forest product. So there's a huge gap. Now, even to rehabilitate this project, refurbish these projects, if PNG Power needs to shut down for, let's say, 1 year, 2 year, then the power backup is being a very big problem. That is why, like even the Ramu one rehabilitation is being delayed. So we are engaged as a consultant. Now the problem is how Ramu Grid will get the power if this project will be like shutting down, like for rehabilitation. So how to supply that power? And if we supply by diesel plant, is very costly. That 1 or 2 years cost of diesel can, for one equivalent energy, can build a project to to the capacity of that equivalent energy it can generate from genset. So If you invest 2 years, the cost of investing 2 years in diesel can build the project of the same size, or which can generate the equivalent amount of energy, then you will get the benefit for 50 years. So it's being a real challenges, but there are different innovative, there are different solutions we're looking after, even though like sequencing, the refurbishment of the replacement of these units. So this is challenges in refurbishment. So other challenges apart from core engineering challenges are infrastructure, like we don't have national grid, we don't have the transmission line network distributed throughout the country. So even if the hydropower projects normally are all located in remote area, so it requires building a long transmission line. Access road, as we all know that the PNG, we don't have the proper road network within the country, and especially because of scattered populations and hydropower projects being located in very remote places. This is one challenges for the development of hydropower projects, which requires initial like funding for access road. And the climate, like I said before, is sometimes during the concreting you might need to have a special arrangement due to account for higher temperature. So climate vulnerabilities. So if you all know that, like because of tropical climate, the rainfall is the blessing for PNG for power generation, but sometimes the same rainfall can induce the landslide, and we can have the rainfall induced landslide and even the seismicity induced landslides. So we need to have a proper assessment of the landslide when we're doing our project layout and planning, and we need to have the proper slope protection measure to overcome any like possible landslide failures. So these are the challenges. Like I said, scattered population, so that there's no proper grid. So there's no proper grid network, and land acquisition and social aspect is one great challenges, and especially in PNG because of customary land. So I think as an engineering community, so we need to advocate maybe our non-engineering uh, peers or friends or non-relatives, that the development of such projects will be beneficial for the community. So this should be supportive in terms of land agreement, or in terms of social aspect to bring the development in the country. Because where I want to highlight this when the engineering community is here is that if you see, because of social things, like it took so long time in some of the project to manage the social things. The IFI, like International Funding Institute, like ADB, World Bank, if you see DFAC, they are trying to not to fund in the greenfield projects, because the social management of the social aspect is and the land acquisition is very difficult. So they are trying to divert the fund in brownfield, like refurbishment. So and it will also poses challenges for the private developer, even for the PPL, if the problems of the land acquisition or the social aspect management remains as it is. So we as an engineering community and should advocate to our local people and to your relatives, to your clients. So I think you, as a responsible citizen and engineers, need to advocate on this. So and another important thing is gap in the development of local resources. So if you see the like I said, all these hydropower projects were built maybe 40, 50 years before, when even there was no maybe proper engineering resources in the country, which was done mainly by international expert, because it was hydropower is very specialized field of engineering. And so there was a gap because there was no development of such projects in the country, and there was a gap of local engineering resources. But at SMEC, like we're committed in development of the competent local resources in hydropower sector. So we have almost 13 national engineers and geologists who are working with international team here in PNG and also with our international experts or experts in the field, like veterans who are based in Kuala Lumpur, Malaysia, and Australia, and supporting all these hydropower projects. Sorry, I'm running out of time, so I'll uh, Puri Brian. So can I go another 5 minutes?
Hey, Sujan. Yeah, if you don't have a backend, you can go 5 minutes.
Yeah, okay. So now opportunities, like I said, in terms of engineering, there are a lot of opportunities. Whoever the engineers are involved can get involved in the complex project and different disciplines of hydropower projects. And if we go in detail, there are a lot of things to learn. And in terms of general opportunities of the hydropower projects, is that like it provides, like I said, it provides the clean green energy. Like as of now, we have only 250 megawatt out of 330 megawatt hydro projects like were built in like 90s. So there's a lot of potential. So if we explore these hydro potentials in the country, it will help for the industrial, even in the mining and resource sector, the development of the it will help a lot in the development of the country. And nowadays, like these, all the world is talking about net zero to reduce the carbon emissions. And for PNG, it's very easy. So they have natural blessing of the hydropower, which they can use for as a source of renewable energy. And energy security now is a global priority. So you might have. From my experience, when I came to PNG 7 years before to now, the price of diesel or fuel is increasing. I think maybe it's now almost doubled. But the fuel is fossil fuel. You have to depend on global market. So any international politics, anything can impact the supply of fuel or these things. But if you have your homegrown resources like hydropower, you don't need to worry what's happening outside. So you can have the consistent supply of the power. So this is one project like SMEC is doing, like hydropower project potential in Pinsap. Then parallelly, SMEC was one of our, like our mother company, Surbana Jurong Group, was involved in special economic zone study. As we have the specialization in similar study in Singapore. So how it can benefit, you can look like here we have coastal region and near to, like this is the example of Finsafen. So here you can generate 500 to 700 megawatt of hydropower projects. You can establish a special economic zone and attract industries. Like a lot of potential is here in PNG, like downstream processing, timber, fish, coconut. In terms of agriculture, cocoa, there's nickel, downstream processing, gold refinery, copper smelting. There are a lot of potential in PNG in terms of industrial growth. And now the power is very key factor. I'm in discussion with a lot of SCJs and a lot of companies who are trying to do such downstream facilities, even the coal minerals are like a lot of they're trying to do, but now the constraint is power. If they need to supply power with diesel or fossil fuel, it's being too costly. And now the country, there's a lot of gap in the development of hydropower projects, and the country is not prepared to develop the hydropower projects very quickly. It will still take some time, but there's no choice. Ultimately, they have to go for this, and which will benefit the development of the country, like in terms of industrial growth. I have shown here the example of Sarawak in Malaysia, where hydro projects has driven the industrial growth with clean green energy. So in the resource and mining sector, yes, definitely now most of our resources and energy sectors are using gas or maybe non-renewables. But at one point, they are also now being obliged to go for renewable energy. And in terms of environment, all these carbon emissions, and in terms of cost-effective measures, hydro will definitely play a major role in supplying power to all resource projects, even existing proposed one. There are a lot of expansion going on in some of the mining companies like Kainan to Ramonikal, which are in need of like huge amount of power, and PPL is already struggling to provide the power. So there's a lot of opportunities in hydropower developments in the country. This is for SEZs and SMEC efforts. So we normally in these recent years, 5, 7 years, we have been mostly involved in, like I said, a lot of stages. So we are involved, mainly involved, though we have done like involved in almost all the projects, like even in EDW, they've been a construction stage, but mostly majority of the feasibility studies we're doing now, so which are forming the backbone for the next stage development of the country. And working in hydropower sectors in the initial phase is not easy. You have to have your commitment, you have to have your dedications, and uh, uh, we are developing the local PNG resources to be competent in the hydropower sector in the country. So thank you. That's all. Uh, so if any questions,
Thank you
hello.
so much, Sujan. Um, Thank you everyone else for also joining in. Sujan, truly appreciate the detail into this presentation. Since we've just gone over 6 minutes of time, I'm pretty sure a few of us might have backends. If you don't mind, if anyone has questions, probably they could reach out to you in LinkedIn, if that's okay with you, Sujan. But to everyone else, truly appreciate you joining. We aim to do this knowledge sharing hopefully once a month, and we'll try to have one next month as well. But Sujan, thank you so much for the in-depth discussion into the challenges and opportunities we have in hydropower and PNG. And yeah, thank you everyone, and hope you all have a great weekend.
Thank you. Thank you so much. Have a good weekend. So yeah, I think just a quick one. So it's a very good initiative done by IEPNG Port Moresby branch and the voluntary services by the young engineers. So SMEC is interested to if any opportunity for like our other exports in other fields are also interested. So I think we need to join all the engineering communities and keep this going. Thank you so much.
Thank you so
Thank
much,
you.
Sujan.
You.
Well,
Bye.
Puri and I will take note on this.
Thank you. Bye.